Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the value of each interior angle of a polygon. This is just a direct extension of the previous one we did, focusing on how to determine the measure of interior angle of all the polygons. That is the sum of interior angles of a polygon. But this time around, we want each. So without much ado, let's quickly go into it. Now, to recap on what we did, we knew, or we got to understand, that the sum of interior angles of a polygon is giving us n minus 2 times 180. What do we mean by the sum of interior angles? So the interior angles are the angles inside the polygon. For this, you can say this angle, this here, this, and then this. If we add all of them, the answer we'll get is what we call the sum of interior angles of a regular polygon. Now, it is important we understand what a regular polygon is and what an irregular polygon is. When we talk of a regular polygon is a polygon that has both equiangular and equilateral sides. You see, so when we are talking of equiangular, it simply means all the angles are the same. And then if it is equilateral, it means all the sides are also the same. With this in mind, then we realize that even though we have a lot of triangles, we have the scalene, and as you can see, we have a scalene triangle. All the sides are different. Okay, so this side is different to this, and then all of these ones, they are all different. Then this is a right angle triangle. The hypotenuse is longer than all the other two sides. Okay, but when we look at an equilateral triangle, that is what we have over here. This side is the same as this, and is the same as this. So when we talk of the triangles, then the regular, or the triangle, the one that is a regular polygon, would actually be an equilateral triangle. You see, the same applies to the quadrilaterals as well. So for the quadrilaterals, as you see here, this is a square. This one is completely irregular. This is a rectangle, and this is a kite. Now, for a square, all the sides are the same. So this side is the same as what you have over here. It is the same as what you have over here, and then this as well. But for this, you realize that everything is just so different. They are all different. For a rectangle as well, this is the same as this, and this one's length is the same as this length, and the same applies also to the kite. Now, per our definition, and it simply means it is only a square that is a regular quadrilateral. First of all, because it is equilateral. Equilateral meaning all the sides are the same. And also because it is equiangular. So this angle here is the same as this angle, and is the same as this angle, and it is also the same as this angle. Same apply to the, what do you call it, the equilateral triangle. All are the same. Even though for a rectangle, all the angles are the same, hence we can say it is equiangular, but it is not equilateral, meaning that the lines are not the same. You see, so with all this said, let's look at the formula we can use to calculate the value of the interior angle of a regular polygon. That is, you just want one of them, one of the interior angles. Now, the formula for a single interior angle, we'll denote that with A. Note that in a regular polygon, since all the end sides are the same, as we have shown over here, since all the sides are the same, then after finding the total of the sum of all the angles, you just divide it by n, and that will give you each. You see, so we say a single interior angle is equal to what? N minus 2 times 180, which you have seen before as the sum of interior angles. divided by the number of sides. So all you need to do is calculate the sum of interior angles divided by the number of sides, and that is all. With this, let's try and see if we can solve some few examples. So for our first question here, it says find the measure of one interior angle in a regular pentagon. Find the measure of one interior angle in a regular pentagon. So we know that an interior angle, so A is equal to n minus 2, then times your 180 all over the number of sides. Now, since they are talking of a pentagon, then we should know that the number of sides they are talking about is 5. You see, now we would have to do our substitution. So it simply means the sum of the interior angle is equal to your n, which is 5 minus 2, then times your 180 all over your 5. Now, if you get to this stage, it all has to do with your knowledge on fractions, simplification, algebra, and all that. Okay, so 5 minus 2 gives us a 3. So you have 3 times 180 all over 5. You can choose to do your simplification. So choosing to simplify, we have 5 dividing itself 1, and then into 180 36 times. So all we do have now is to find 3 times 36, which gives us a 108. So it simply implies that the value of each interior angle of a pentagon, in this case of a regular pentagon, you now know the difference between a regular polygon and then an irregular polygon. So we are talking of a regular pentagon, and the value of its interior angle is 108 degrees. As simple as you see. So this is going to be our last question. It's also very simple and direct. If you do understand what we've done so far, you can choose to pause the video and then try on your own. Now, if you're able to do it on your own, you can put your answer in the comment section. Now, let's do it together. It says, find the measure of one interior angle in a regular decagon. In a regular decagon. So you should know that when you are talking of a decagon, decagon simply implies that it implies the number of sides is equal to 10. You see, so if the number of sides is equal to 10, then for the interior angle, which is given by the formula n minus 2 times your 180 all over your n. Doing our appropriate substitution, we have 10 minus 2, then times our 180 all over your 10. You see, so simplifying further, we know our A is going to give us 10 minus 2, which is 8. Then we have times 180 all over 10. Now, this 10 divides 180 how many times? 18 times. So you are just left with 8 times 18. Hence our A, which is the angle in question, would then be what? 8 times 18, which gives us a 144 degrees. As simple as that. So it simply means the measure of one interior angle in a regular decagon is 144 degrees. This is how far this video is going to go. And you should get to know that any other question relating to this topic would just be to test your understanding on other aspects of mathematics, that is maybe in algebra, your change of subject and all that. If you know the basic formula, you are good to go. As usual, I'll leave you with some exercises you can try on your own, and there are 3 of them, as you can see on your screen. Very, very simple and direct. This is How Beyond Numbers, where we learn maths the easy way. If this was your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and then bye for now. Stay blessed.